Now let's take on to question number 6. In question number 6, here we have, starting from rest from a point A, a ball rolls down without slipping on part AB of the track, which is rough. Part BC of the track is smooth. C is the highest point reached by the ball on the smooth part. Ka, Kb, Kc are kinetic energies at point A, B and C respectively then. Well, from here to here, all of the potential energy will convert into the kinetic energy, some as a translational kinetic energy and some as the rotational kinetic energy at this point. But from here onwards, only the translational kinetic energy will be converting into the potential energy and the particles shall have the rotational kinetic energy. So what I would say, kinetic energy will be maximum at point B and height of HA will be higher than height of HC. So looking onto the options, kinetic energy of B is greater than C. Both of these two options are having the kinetic energy B greater than C, and HA should be higher than HC, I say. So looking onto the option, here is HA is higher than HC. For question number 6, option 4 is the correct answer. In question number 7, the position vector of a particle is given by r is equal to 4ti plus 3t minus 2t square j, where all quantities are in SI units. The angle between velocity vector and acceleration vector at t is equal to 1 second. Quite simple. What we need to find out here is the velocity and acceleration. R to be given as 4ti plus 3t minus 2t square j. One derivative, first derivative will give us the velocity here, that is 4 in I direction plus 3 minus 4t in j direction. Second derivative will give us the acceleration vector. It is simply this derivative would be 0 and this derivative would be 0. I'm left with minus 4 in j. So what we calculated here is, if I'm taking this to be x direction, this to be y direction, acceleration is along this direction only, and the velocity from here at t is equal to 1 second is 4i, and putting the value 1 here, I'll get it minus j. So velocity is 1 along this direction, 4 along this direction. So, well, I would say this is the velocity vector, this is 4, this will be root 17. This angle theta. This angle theta is the direct angle between the velocity vector and negative y direction along which the acceleration was. So simply this is the required answer. Looking onto the options, the answer was given in terms of cos inverse. So I would say cos inverse 1 by root 17 is the angle between the velocity vector and acceleration vector at t is equal to 1 second. For question number 7, option 2 is the correct answer. Here in question number 8, a projectile is given an initial velocity of 3i plus 4j meter per second, where I is along horizontal and j is along the vertical direction. The equation of trajectory, if g to be taken as 10 meter per second square, is straight away I'll writing down the equation of trajectory, that will be y is equal to x of tan theta minus 1 by 2 g x square divided by u square cos square theta. This portion u square cos theta or u square cos square theta is the square of the velocity along x direction. Already we have been provided with the option x. Tan theta from here is 4 divided by 3 minus g to be taken as 10 by 2 x square. This part is the velocity component in x direction, that is 3. So square of that part will be 9. This will be 5. Well, y is equal to, this is 12x by 9 minus 5x square by 9, or I would say 9y must be equal to 12x minus 5x square. So for question number 8, 9y is equal to 12x minus 5x square, that is option 3 is the correct answer. In question number 9, A particle of mass m is equal to 2 kg is attached to the end of a string of length 1 meter. The particle is rotated along a horizontal circular path about vertical axis. It is observed that string just breaks at the angular velocity of 20 radian per second. Then breaking strength of the string. We need to find out the force that this string will be bearing before breaking. Straight away, well, I would say this mass will be rotating along this direction. It is the tension that will be providing the necessary centripetal force, and the maximum limit that already been given, that it breaks at angular speed of 20 radian per second. I would simply say tension, breaking strength actually, that is m omega square into x. Put the value of m to be 2 kg, omega to be given as 20, so it will be 20 into 20. Distance x was 1 meter, so breaking strength will be, this is 800 Newton. Option 4 is the correct answer for the question number 9. Question number 10. Find the acceleration of block A and B over the fixed wedge as shown in figure. There is no friction between the blocks and the wedge. We need to find out how much the acceleration of this blocks would be. Well, along the direction 2 mg sine 53, 2 capital mg sine 53, we know it will be 4 by 5. Along this direction it is mg sine 37, it will be 3 by 5. Total mass is how much? That is 3m. This will be the value of the acceleration here. Well, 4 into 2, 8 minus 3, it is 5 mg divided by 5 into 3m is the acceleration, and that is, this will cancel out. G by 3 is the required acceleration here. Clearly, G by 3 means how much? It is 10 by 3. It will be 3.3 around meter per second square. For our question number 10, option 2, 3.3 meter per second square is the acceleration of the blocks here. Now let's take on to the question number 11.